This presentation provides an overview of the NSF-funded National Nanotechnology Coordinated Infrastructure Program, or NNCI, its objectives, its resources, and information on how to access these resources. The NNCI is the latest of several NSF-funded nanotechnology infrastructure programs dating all the way back to 1977, when the National Research and Resource Facility for Submicron Structures was established at Cornell University. As you know, the National Nanotechnology Initiative, or NNI, was proposed by President Clinton in 2000 and signed into law by President Bush in 2003. With one of the goals of the NNI being to develop and sustain educational resources, a skilled workforce, and a dynamic infrastructure and toolset to advance nanotechnology, the NSF-funded Nanotechnology Infrastructure Program saw a considerable expansion with the start of the National Nanotechnology Infrastructure Network, or NNIN, in 2004. Finally, in 2015, the NSF began funding the National Nanotechnology Coordinated Infrastructure, initially for 5 years and renewed in 2020 for another 5 years. It should be mentioned that the NSF-funded NNCI is only one pillar of the National Nanotechnology Infrastructure, complemented by the 5 nanoscale science research centers funded by the Department of Energy, the Center for Nanoscale Science and Technology at the National Institute of Standards and Technology, and the Nanotechnology Characterization Laboratory at the National Cancer Institute being additional resources. The NNCI comprises 16 sites along with 13 partner institutions that are geographically distributed across the United States. 8 of the 16 sites were part of the previous NNIN network. Together, the network operates 69 distinct facilities that house over 2,200 research tools. The NNCI network includes a coordinating office located at Georgia Tech in Atlanta. The NSF investment of $165 million over 10 years is leveraged by tremendous investments of the NNCI sites and their partners into state-of-the-art facilities, tools, and the staff to operate these facilities. It is estimated that the overall capital investment into these facilities is likely in the $2 to $3 billion range, with the annual operating budgets on top. The goals of the NNCI are to provide open access on a fee-for-use basis to these state-of-the-art nanofabrication and characterization facilities, their tools, and associated staff expertise. The latter cannot be emphasized enough, as expert staff is critical for the successful operation of these facilities. In addition, the NNCI uses these resources to support a wide range of educational and outreach programs, as well as programs on societal and ethical implications of nanotechnology. Last but not least, the NNCI strives to make the whole more than the sum of the parts through a variety of multi-site programs and initiatives. The following numbers best highlight the scope of the NNCI facilities. In year 4 of the network, that means between October 2018 and September 2019, the network infrastructure was used by 13,355 unique users, of which 3,852, or 28.8%, were external to the NNCI sites and their partners. To put this into perspective, when the NNIN started in 2004, shortly after the start of the NNI, there were 3,350 annual users, translating into a 4-fold growth over the past 15 years. The external users in year 4 of the NNCI include nearly 2,000 industry users, representing 600 small companies and 234 large companies, as well as more than 1,500 external academic users representing 247 universities and colleges. In addition, 30 government organizations as well as dozens of international organizations use the NNCI resources in year 4 of the network. Each month, more than 5,000 users utilize the NNCI facilities, and more than 5,000 new users are trained every year, most of them graduate students. It is estimated that 10 to 20% of the PhD students in science and engineering in the US use NNCI facilities. In year 4 of the network, these users logged more than 1.1 million hours in the NNCI facilities, with almost 300,000 hours coming from external users. This map shows the location of the 247 US academic institutions that used NNCI resources in year 4 of the network in blue, along with the location of the 16 NNCI sites and their 13 partners in green. The map nicely highlights the broad reach of the network, with users coming from 46 states as well as Puerto Rico. At the core of the NNCI are the site's micro and nanoscale fabrication and characterization facilities that serve a broad range of communities and support materials research, device research, up to systems research and their applications in, for example, medicine and life sciences, as well as geology and earth sciences. The network also offers computational and modeling resources to support nanoscale science and engineering, and uses its tools and staff resources to support a broad range of education and outreach programs, as well as programs on societal and ethical implications of nanotechnology. Details on these programs can be found on the NNCI website, nnci.net. Looking particularly at the NNCI nanofabrication and characterization resources, the network sites and their partners have the ability to deposit and structure at the nanoscale a variety of materials, including metals, semiconductors, dielectrics, as well as a large number of soft materials. Sites support top-down, lithography-defined nanofabrication techniques, including optical and electron beam lithography, etching, as well as extensive material deposition and growth capabilities, as well as bottom-up material synthesis-based nanofabrication. These fabrication resources are complemented by extensive nanoscale imaging and surface metrology capabilities, including high-resolution electron microscopy. It is worth mentioning that while certain sites are considered generalists that offer a broad range of technologies and expertise, other sites have particular focus areas, including, for example, additive and subtractive manufacturing, or target specific user groups, such as geology and earth sciences. Again, details can be found on the NNCI website, which in particular includes, besides description of the 16 sites and their partners, searchable tool and expert databases with the links shown here. How can you become a user? Most importantly, user access is handled by the individual sites, with access requirements and cost structure defined by individual sites and their core facilities. Common to all sites is the goal of easy access with minimal or no proposal involvement, rolling applications, and the availability of academic rates. Sites offer either on-site usage, where the researcher is trained to use a piece of equipment and then uses it by him or herself, or remote access, where site staff performs the work on behalf of the user. Many sites offer both access methods. Billing is by usage, and many sites have seed grant programs available to help first-time users. Again, details on how to become a user can be found on the NNCI page with a specific link shown here. For further inquiries, please either contact the local site directly or complete an online form. Thank you for your attention. And again, if you want to learn more about the NNCI, its capabilities and programs, please visit www.nnci.net or email one of the authors of this presentation. You can also learn more about the NNI and the impact nanotechnology has had and will continue to have at nano.gov.